For years, a terrifying headline has haunted climate science. Europe is on the verge of a new ice age. At the same time, the entire east coast of the United States braces for catastrophic, permanent flooding. The culprit? The collapse of a single, vital system deep within the Atlantic Ocean, the planet's beating heart. Scientists have warned us that this colossal engine is slowing down, grinding to a halt under the weight of climate change. But what if the story isn't that simple? What if, in a shocking twist, the planet itself has deployed a secret, hidden backup system to save us from the brink? Today, we're diving into one of the most critical and complex systems on Earth, the Atlantic Meridional Overturning Circulation, better known as the AMOC. This isn't just some obscure scientific term. It's the giant oceanic conveyor belt that dictates the climate for hundreds of millions of people. A massive river within the ocean that has shaped human history, and right now, it is in unprecedented trouble. In this deep dive, we're going to unravel the mystery. We'll expose exactly how our warming world is choking this planetary life support system. We'll reveal the stunning, newly discovered process in the high Arctic that scientists are calling a backup generator for the entire Atlantic. But is this our planet's get-out-of-jail-free card? Or is it merely a temporary reprieve, a short-term patch on a system that is fundamentally broken? And what terrifying, unknown consequences could this new fix unleash? The answer could redefine our future. To understand the stakes, you have to picture the AMOC for what it is, a gargantuan, planetary-scale conveyor belt. It's the circulatory system of the Atlantic Ocean. It works like this. Warm, salty surface water from the tropics flows northward, like a massive warm river, releasing incredible amounts of heat into the atmosphere. This is the single biggest reason why Western Europe, from the United Kingdom to Scandinavia, enjoys a climate far milder than, say, Canada, even though they sit at similar latitudes. London's weather has more in common with Paris than it does with the frigid landscapes of Labrador, and it's all thanks to this current. But the journey north is only half the story. As this water travels, it becomes cooler and, due to evaporation, saltier. By the time it reaches the frigid regions near Greenland and the Nordic seas, that's the Greenland, Norwegian, and Iceland seas, it has become so cold and so salty that it is denser than the water beneath it, and so it sinks. It cascades thousands of meters down to the ocean floor, in a process scientists call deep water formation. This sinking acts as the engine of the entire system. It pulls more warm water from the south to replace it, and the deep, cold water then begins its slow, silent journey back south along the ocean floor. Eventually, it rises back to the surface near Antarctica, and the cycle begins anew. This elegant, powerful system has been stable for thousands of years, but now it's failing. The alarm bells have been ringing for years, with study after study suggesting the AMOC is at its weakest point in over a millennium. A full collapse is no longer a fringe theory. It's considered a plausible, if terrifying, reality within this century. The consequences would be nothing short of biblical. Northern Europe would see average temperatures plummet by 5 to 10 degrees Celsius, or even more. This isn't just about needing a warmer coat. It's about a return to conditions not seen since the Little Ice Age, where the Thames in London froze solid and Scandinavian ports were locked in ice for months on end. Agriculture, adapted to centuries of mild Gulf Stream weather, would collapse. Energy grids would buckle under the demand for heating. Entire economies would be thrown into chaos. Meanwhile, the disruption would cause sea levels along the U.S. East Coast to rise dramatically and rapidly, far faster than the global average, as the current that normally pulls water away from the coast weakens, allowing it to pile up. This would inundate coastal cities from Miami to Boston, not in some distant future, but with a speed that would make planned retreat impossible. Weather patterns would be thrown into disarray globally, affecting everything from the intensity of hurricanes to the location of vital monsoon rains that billions of people in South Asia and Africa depend on for food and water, potentially triggering widespread famine and unprecedented geopolitical instability. The reason for this impending catastrophe is tragically simple. We are breaking the engine. Climate change is warming the planet, which means the surface waters flowing north aren't losing as much heat to the atmosphere. They arrive in the North Atlantic still too warm to sink effectively. But there's a second, even more powerful blow. As the Arctic and the Greenland ice sheet melt at an accelerating rate, they pour unfathomable amounts of cold, fresh water into the ocean. This isn't a trickle, it's a deluge. This meltwater acts like a poison to the AMOC's engine. It drapes a buoyant blanket of fresh water over the ocean surface, a less dense lid that physically blocks the heavier, saltier water from sinking, no matter how cold it gets. The Great Cascade to the ocean floor falters, the conveyor belt slows, and the entire system threatens to shut down. It's a bleak picture. But just when the outlook seemed its most dire, a team of scientists from the University of Bergen and Norway, led by physical oceanographer Marius Arthun, published a groundbreaking study in the journal Science Advances. Their findings suggest that the story is far more complex and that the Atlantic may have a hidden ace up its sleeve. Using sophisticated computer models fed with decades of real-world density measurements, they confirmed that dense water formation in the traditional Nordic seas has indeed decreased since 1993. The engine is sputtering, just as we feared. But then they found something else, something that wasn't supposed to be happening. They discovered that as the traditional engine was failing, a new one was starting up, hundreds of miles away in an entirely different part of the world, the Arctic Ocean. The researchers have named this phenomenon Atlantification. It's a term that describes the transition of the Arctic from a cold, ice-covered world to a warmer, more ice-free Atlantic-like state. For decades, we've watched in horror as the sea ice in the Barents Sea, a vast region of the Arctic north of Scandinavia and Russia, has retreated farther and farther north each year. This retreat is a clear and tragic sign of our warming planet. But according to this new research, it has had an unintended and potentially world-saving side effect. As the ice disappears, it exposes a much larger area of the ocean surface to the frigid Arctic air. The warm Atlantic waters that are now able to push farther north into this region lose their heat rapidly, become saltier, and begin to sink, forming dense water in a place it previously couldn't. In essence, the Barents Sea and the areas north of Svalbard are becoming a new secondary engine for the AMOC. The study found that the increase in dense water formation in these new Arctic regions has been almost perfectly compensating for the decrease in the traditional Nordic seas. It's an incredible example of the planet's resilience, a natural mechanism kicking in to counterbalance our own impact. If you find this planetary plot twist as fascinating as I do me a favor and hit that like button to let us know. It really helps us understand what topics you want to see more of. So, does this mean we can all breathe a sigh of relief? Has the Earth's secret backup system saved us from a climate catastrophe? Well, before we celebrate, we need to take a very serious reality check. The same scientists who made this discovery, and others in the field, are urging extreme caution. This is not a get-out-of-jail-free card. It's a temporary reprieve, and one that comes with a host of massive, unanswered questions. The first and most critical question is, can this Arctic backup system really do the job in the long run? Nicholas Foucault, a physical oceanographer at the University of Georgia who was not involved in the study, raises a crucial point of skepticism. The water masses historically formed in the Greenland Sea were not just dense, they were incredibly dense. The Greenland Sea is a unique environment. It's a very deep ocean basin that is constantly exposed to frigid, powerful gusts of wind blowing off the massive Greenland ice sheet. This combination of factors creates some of the densest water on the entire planet. As Foucault points out, the Arctic does not have this type of setting. The Barents Sea is much shallower. While it's now forming dense water, it's highly unlikely that this water is as intensely dense as what was being produced in the Greenland Sea. He states it plainly. I doubt that these really dense waters are being formed in the Arctic. This is a critical distinction. It's like replacing a V8 engine with a 4-cylinder. The smaller engine might keep the car moving for a while, but can it really power the entire vehicle up a steep hill? Can the less dense water being formed in the Arctic truly sustain the immense power and scale of the entire Atlantic meridional overturning circulation for decades to come? Or will the overall circulation continue to weaken, just more slowly than predicted? The second major question is about time. How long will this Atlantification process even last? The very thing enabling this backup system, the retreat of sea ice, is a symptom of a planet that continues to warm. The researchers themselves expect the Barents Sea to be the first region of the Arctic to become completely ice-free year-round. What happens then? When there's no more ice to retreat, does this new engine simply shut down as well? We might just be witnessing a temporary phase, a brief window where conditions are just right for this compensation to occur before warming temperatures overwhelm this system too. Furthermore, there is a third, deeply unsettling question. What are the ecological consequences of this fix? The Arctic Ocean is not an empty basin waiting to be used. It is a unique, fragile ecosystem. The rapid influx of warmer, saltier Atlantic water is a biological invasion. What happens to the native Arctic cod, the seals, and the polar bears that have evolved over millennia to thrive in their specific frigid environment? This solution could trigger a catastrophic collapse of the entire Arctic food web, a devastating price to pay for a temporary reprieve for the Atlantic circulation. This discovery, then, doesn't solve the problem of the AMOC slowdown. It adds a layer of profound complexity. It shows us that the Earth's climate is not a simple machine with on-off switches, but an incredibly intricate, dynamic system with feedback loops and self-regulating mechanisms that we are only just beginning to understand. The AMOC is still in danger. The fundamental physics haven't changed. Pouring warm, fresh water into the North Atlantic is a recipe for disaster. What has changed is our understanding of the timeline. This Arctic backup system may be buying us time to understand the system better, and most importantly, time to act decisively to curb the climate change that is causing the problem in the first place. The story of the AMOC is no longer a simple tale of collapse. It's now a dramatic race, a story of human-caused disruption being met with a surprising, powerful, but ultimately mysterious planetary response. We have been given a warning, and now, perhaps, a brief window of opportunity. Pushing our planet's systems to their breaking point has consequences we cannot predict, and uncovering one failsafe only raises the terrifying question of what happens when we break that too. What other hidden mechanisms are at play in our oceans and atmosphere? To keep exploring these critical planetary secrets with us, make sure you're subscribed and hit that notification bell. You won't want to miss what we uncover next.